Hello, in this series of videos, I want to go over how to solve or answer all the questions on this Chapter 6 review worksheet. So I'll have a solutions key posted on Canvas with all these detailed solutions, but I wanted to go through some of these with a video. So here we've got looking at the normal distribution, which we use the variable z, in the student t distribution using students t. And I want to know just what's the probability that t or z are greater than 2. So remember, z or t greater than 2 means that we are looking at 2 standard deviations above the mean or the center of the distribution. So I want to look at and compare these when degrees of freedom is 3, 10, and 100. So to do that, I'm going to go into stat key, which I have in the background. And I'm going to go to the t distribution, type in degrees of freedom 3, click OK. And since we want the probability that t is greater than 2, I'm looking at a right tail. And I want to make this bottom entry change to the cutoff of 2. And we get 0.07 as the answer. 0.07. And what happens if we change that degrees of freedom from 3 to 10? Edit parameters, make that 10. Click on right tail, change this bottom entry to 2, 0.037. And then lastly, what if we have 100 degrees of freedom? Edit parameter, change that 10 to a 100, click OK. Right tail. On the bottom, we're going to click on 2, and I get a 0.02. 0.024. So then what I'm going to do is compare that to the normal distribution. What happens when we take z greater than 2? So if I want the z distribution, I'm going to go outside of stat key, on the main page in stat key, click on normal. And when we're looking at z, don't forget that that means the mean is 0, standard deviation is 1, so I don't need to change these parameters at all. Click on right tail, change this bottom entry to a 2, my cutoff, click OK, and I get a 0.023. So what we want to notice here is that as the degrees of freedom get larger and larger, what happens is the t distribution gets closer and closer to the z distribution. So if we plugged in 1,000 or 1,000,000 degrees of freedom, then basically t and z would be identical. So if we're looking at t star for the 90%, 95%, 99%, let's do the z value first since we're already in here. I'm going to click on the 2 tail. And if the middle is 90%, that's the 1.645. 1.645. 95% is 1.96, and 99%, I believe, is 2.5, but I'm going to go change it in here. The middle is 99%, 2.575. 2.575. So those are my cutoffs. And I want to know how these differ from when we go to t distribution with a fairly small sample size 4 or 3 degrees of freedom. So we go back out, switch on the t for t distribution, click on 3 degrees of freedom, and if I click on 2 tail, 95%, I get 3.183. Oh, excuse me, that's the 95%. 3.183. And if I want 90%, change the middle to 0.90, click OK, 2.353. Don't forget, we could do plus or minuses in here since we're thinking about this in terms of confidence intervals. So I'll do the positive cutoff value. And for 99%, 5.842. So the reason I wanted to go over this specific example is that with a smaller sample size, notice the t is significantly larger than the z-score. 2.35 versus 1.64, and then 99% 5.8. So with a smaller sample size, we use t-distribution to get a larger confidence interval. And the reason why we do this is we have less information. We have a smaller sample size, so that t-distribution was designed and has been vetted and looked at with a lot of different data over the last 100 years or so, and it matches fairly nicely with most real-life applications. And the idea being we need to make a larger confidence interval because we have less information.